So Isabel and Ani and I are very pleased to present Dr. David Huron. We only gave David 30 minutes this morning. He has another talk on Monday and a talk this evening, and so we're working our faculty pretty hard. But everyone felt we couldn't close a session this morning on music and emotion without David talking to us. And for those of us, me, who got to first experience David in September, I think I learned some of the most profound things from him. So I'm really looking forward to your talk, David.
Thank you very much. I would also like to extend my thanks to Cheryl and Mark and Steve and to the Santa Fe Chamber Music Festival and to the Gabrielle's Angel Foundation. It's really a splendid opportunity here. I think we have far too many of these barriers that prevent us from talking across disciplines. So, are we up? There we go. Okay, if we were talking about some questions related to music and emotion, we might start off with some general questions. What is an emotion? Are emotions learned or are they innate? Does everyone experience the same emotions? And how does personality or gender or culture influence the experiences of emotion, including the expressions of emotions? If we focus more specifically on sound, we might ask questions such as what makes a sound sound happy or what makes a sound sound sad? Are the emotions that can't be conveyed by sound? Are acoustical features of emotions the same in all cultures? And then if we narrowed our questions even further, we might then focus in on some musical questions. Are there emotions that can't be conveyed by music? When listening to music of another culture, do we hear the same emotions? Do we perceive and are we affected in the same way? And how does music evoke emotion in listeners? So philosophers like to make a distinction between what music might express. So for example, you might say that's a sad piece of music, but on the other hand, it might not make you feel particularly sad. It might make you feel angry or happy or disgusted or something. So we need to make a distinction between the representation of the affect and what's actually evoked in listeners. In the last 5 years in my lab, we've been particularly influenced by concepts in ethology. That is the study of animal behavior. And ethologists make a useful distinction between signals and cues. A signal is a purposeful communicative act involving an innate behavior and physiological mechanisms that change the behavior of the observer. And a classic example of this for animal behavior people would be a rattlesnake's rattle. So when the rattlesnake, of course, when it's hunting, field mice and so on, it doesn't use its rattle because that would just scare away its prey. It uses it when it's in a state of fear, and basically it's involved in mutually assured destruction. It says, you might do damage to me, but I can also do some damage to you. Now, cue is a different sort of thing. It's a non-purposeful behavior that nevertheless conveys information. So an example here might be the buzzing sound made by a mosquito prior to an attack. So you might be in a cabin, sleeping at night, or trying to fall asleep, and you hear that buzz sound, and you think, oh, from past experience, you know there's a strong likelihood that that mosquito is going to come down and attack me. So in the case of both the sound of the rattlesnake's rattle and the sound of the buzzing mosquito, these are sounds that may presage the possibility of an attack. But in one case, it's, well, here we go. Cues are entirely learned through exposure to some environment, and signals are biologically prepared. There is an innate disposition to behave in a particular way, and there's an innate disposition to respond in a particular way when observing the signaling behavior. So both signals and cues are informative, but signals are communicative, whereas cues are artifactual. Okay, so how do ethologists identify whether a particular behavior might be construed as a signal or whether it ought to be looked at as a cue? And there are a number of different factors that ethologists look at, but we have time for just two. One is that signals should be conspicuous. If the whole idea is to be communicative, then you shouldn't be timid or quiet about your signal. You should make it quite obvious that you're going to signal in a particular way. One way of making a signal obvious is by using more than one modality. So signals tend to be multimodal. You can look at this bear and you can see a characteristic facial expression, but we all know that what goes along with this is a particular kind of sound. So in multimodal signals, you'll see often you'll see a visual display and you'll see a characteristic, or hear a characteristic auditory display as well. There might be other modalities as well, like smell and so on. So signals tend to be multimodal. Cues, because they're artifactual, may also be multimodal, but because they're not designed to be communicative, they may be more likely to be unimodal. So one of the best generalizations one can make about behavior is that trying to appear large is one way of being more threatening, and trying to be or appear to be small is one way to appear less threatening. And we see the same relationship in the case of sound. One of the best generalizations we can make about sound or in acoustics is that large or massive vibrators tend to oscillate at low frequencies or vibration, and small masses or small volumes tend to oscillate at a much higher frequency. Eugene Morton, an ethologist at Smithsonian, did a very famous study where he looked at animal calls from a number of different species and tried to see if there were any patterns for these. And what he found was that low pitch throughout the animal kingdom tends to be associated with threatening or aggressive behaviors, and high pitch is associated with submissive or friendly behaviors throughout the animal kingdom. So notice that this is consistent with what you might call sound size symbolism, that appearing to be big or making a low-pitched sound is more aggressive and small sounds are less aggressive or less threatening. Well, we also see this in the case of human behavior. So linguist Dwight Bollinger did a very nice cross-cultural study looking at speech prosody. And what he found was that throughout human societies, when people are speaking in a friendly manner or an affinitive manner, they tend to raise the pitch of their voice. And when they speak in an aggressive or assertive manner, they tend to lower the pitch of their voice. And note that this is consistent with sound size symbolism. Well, we found the same effect in the case of music. So with my colleagues Daryl Kinney and Kristen Prekoda, what we did was we played musical melodies to people, and we asked them to judge how threatening or how polite the melody was and so on. And unbeknownst to them, because they were listening to lots of melodies, they heard the same melodies in 3 different occasions at different transposition levels. So one was a low transposition, a moderate transposition, and a high transposition. And what we found is that transposing the same melody to a lower pitch causes the melody to be judged less polite, less submissive, and more threatening. Well, more recently with a postdoctoral fellow, Daniel Shanahan, we've done a nice study where we looked at the sociability of 300 characters in randomly selected operas. And what we found, this is one of these grandmother research things that anybody who knows anything about opera will say, "Da." Heroes tend to be tenors and sopranos, whereas villains or any character in an opera that scores low on sociability tends to be the lower-pitched voices of basses and contraltos. Well, we've been talking about pitch here, but any linguist would tell you that when we talk about the human voice, we really need to talk about 2 components to this. One is the source. You can think of them as the vocal folds or the vocal cords, which establish the fundamental frequency of vibration. You might think of that as the pitch of the sound. Independently of that, we have a vocal tract, a tube, which has certain resonances to that, and we use both of these when we're engaged in speech. So I can demonstrate the independence of these 2 things, the source and the filter, as follows. So an example of a low resonance would be a vowel like oo, which I can speak in a high-pitched voice, oo, or in a low-pitched voice, oo. And an example of a high resonance would be a vowel like E. And again, I can speak that in a high-pitched voice, E, or a low-pitched voice, E. So we have this opportunity to have 2 different ways of manipulating the source and the filter to have high and low frequency of the fundamental pitch and of the resonance. John Ohala, who's a linguist at University of California, Berkeley, extended Eugene Morton's observations regarding the source component, remember this is the pitch of the sound, to include the filter component to this. As with pitch, resonant frequency arises from body cavities that relate to the body size. So as the cavity is smaller, as the body is smaller, typically the resonant cavities are also smaller. He used this to address a classic enigma in the world of emotion research, and that is, why does the human smile involve the displaying of teeth? Throughout the animal kingdom, showing your teeth is a classic sign of aggression. So why would showing your teeth ever be construed as being friendly or polite or submissive and so on? Well, the key here is Vivian Tarter did a nice study in 1980 and showed that the thing about a smile and what people forget about a smile is that you can hear it. You pick up the telephone and you're talking to a friend and you can hear the sound of the smiling voice. Now, the reason why you can hear this is that the zygomatic muscles that are on the cheeks here pull against this when you smile, and what they do is they pull the lips taut against the teeth. And effectively what happens is it shortens the vocal tract length just a little bit, but enough that you can hear it. So the sound of a smile is, as Ohala points out, really the sound of a cavity that's made smaller. And so is in the classic sound size symbolism vocabulary makes perfect sense. Now you might say, first of all, that, well, wait a minute, people smile all the time without ever talking. Except for the fact that this is true, but people are generally chatterboxes, and whenever you make any kind of facial expression, there's a strong likelihood that from time to time you're going to make some sort of sound. Now, the opposite of the smile would be to take the lips and push them out to produce what you might call a pout, or what Ohala calls the O face. Now, the pout, so when we extend the lips like this, in particular, if we extend the lips, if I start speaking like this, we end up with the classic example of the Hollywood version of the hooligan or the lout. And so this is how you form this kind of aggressive behavior. Again, what you're doing is extending the vocal tract length, and with regard to sound size symbolism, it now says, I'm trying to appear bigger. Okay, so remember that the multimodal tendency, if ethological signals are intended to be communicative, then they should tend to favor multimodal displays over unimodal displays. So it's wrong to regard a smile as solely a visual signal. If the resonance component, this filter component, is visually encoded in the smile and in the pout, then we might ask the question, what about vocal pitch? Remember, we can speak in a low-pitched voice and a high-pitched voice, but if that's an ethological signal, we'd have to ask, what are the visual or other components we'd associate with that? So with some people in my lab, we did a study where we got ordinary people. This was one of those studies that took 3 hours to collect our data and 3 months to get IRB approval. And what we did was we simply went out on the street and we bribed people with ice cream bars on a summer day and asked them if we could take their picture while they sang a note for us. So we'd have them just sing a neutral. These were, of course, not musically trained people. We'd have them sing a neutral pitch, and they go. Non-singers, they don't open their mouths when they sing. They go, eh. We take a picture of them. And then we'd have them sing a high pitch and a low pitch. And then what we did was we took the photographs from this, brought them into the lab, and had other people take a look at the photographs. And we had them judge. They had no idea that the photographs were of people singing. And what we had them do was simply judge which is the friendlier face. So what happens when people sing a low pitch is they drop the chin down, they form a neutral or frowning mouth, and they lower the eyebrows. And when you ask people to sing a high pitch, they raise the chin, they tend to smile, and they raise the eyebrows. The effect is massive. In fact, in a more conservative version of this experiment, we cropped the photographs at the nose, so they were only looking at the upper part of the face. You still find a huge effect size. The pitch of the voice is very strongly correlated with the position of the eyebrows. Well, in fact, you can observe this in video performances of musicians. So it turns out that when pianists are playing, if they start moving down into the low register, they tend to lower their eyebrows. And as they move up into the higher register, they tend to raise their eyebrows. So you can see this actually in real performances. So moving the pitch up and down influences eyebrow placement. What about the other direction? What about the other causality? Does moving one's eyebrows cause the vocal pitch to change? So we carried out another experiment. We asked 31 people to read short sentences aloud while we recorded their voices. And we told them, these were sentences that were displayed on a screen, we told them it was a memory task. This was a real deception, and that they would have to remember these sentences later on. And then to make the task more complicated, we told them we wanted to move their face around in a particular way. So we told them to move their eyebrows. We avoided any reference whatsoever to the metaphor of high and low. So we would instruct them as things like, move your eyebrows towards your hair, or move your eyebrows towards your nose. And then what we did was we calculated the average pitch for each utterance, and what we found was the effect wasn't as big as what we found in the singing case, but we found that high eyebrow placement tends to drag the pitch of the voice upwards. So when you instruct someone to raise their eyebrows, the pitch tends to go up. So raising the pitch of the voice causes the eyebrows to move, raising the eyebrows causes the pitch to move, and these are consistent with a single central motor circuit producing both changes. That is to say, it's consistent with a multimodal tendency of signals. So let's move on and talk about cuteness. So a number of years ago, we did a study in the lab where we played people all sorts of sounds and we asked them to judge how cute these different sounds were. So first of all, people are very reliable about this. They know what the cute sounds are and what the non-cute sounds are. And by the way, and everybody is in agreement. So that's cute, that's not so cute, that's definitely not cute. People really have a good sense of what that is. Now, I don't know what cuteness is. We then took apart these sound-producing apparatus and then tried to analyze what acoustically is conveying cuteness. As I say, I don't know what cuteness is, but I know it's about this big. What we found was that cute sounds were sounds with a small resonant cavity activated by a small amount of energy. The optimum cuteness had a resonant frequency around about 2,000 hertz. Okay. So Voperian and colleagues did this very nice study where they used imaging technology to measure the vocal tract length for children of various ages and as well as adults. And here you see, for example, in the first year from 0 to 12 months, you can see it tends to cluster for babies around about 8 centimeters is the length of the vocal tract. For adults, it's typically more around about 16 centimeters in length. Well, if you calculate the resonant frequency for an 8-centimeter tube, what you end up with is a frequency of about 2,100 hertz. So what happens in case, what we found for all of these sound-producing apparatus that had nothing to do with vocalizations was that the ones that emulated the vocal tract of an infant were the ones judged most cute. Now, infants can make sounds that are manifestly not cute. You know, you pump a lot of energy through that system, that's not a cute sound. But if they're just cooing or gurgling in that little resonant cavity, it'll just melt your heart. So the sounds deemed cute exhibit resonances similar to the vocal tract of an infant, and the sounds do something else. The sounds evoke nurturing and protective behaviors. Now this was kind of a surprise to us. We had all these different plush toys you can imagine. It was wonderful to be able to go to the store, to the toy store, and buy all of these objects that I could then claim on expenses. But I had, in particular, we used to have this, I should have brought this with me, just a darling raccoon. And everybody just falls in love with this raccoon. Now, of course, it's a stuffed toy. It's an inanimate object. If I stomp on the floor, you think nothing of it. If I took this little raccoon and put it on the floor and started stomping on it, you would know that there's something deeply disturbed about Professor Huron. So well, the first thing that what happens with these things is people want to cuddle them, they want to nurture and protect them. In a word, they're engaged in parenting behaviors. What's interesting is it generalizes beyond a baby. So what we find in a little ocarina or a little sopranino recorder or little music boxes, they all have a small resonant cavity activated by a small amount of energy. So let's listen to an example of this. Helen Kane was a popular singer in the United States in the 1920s, and she had a very small head. And so you can see that she has a rather small mouth, and she produced this rather cutesy little girl kind of sound. Let's just listen to her.
I want to be loved by you, just you, nobody else but you. I want to be loved by you, alone. Boop, boop, ba-doo.
Okay. Now, Helen Kane was actually the model for a famous cartoon character, in fact, Betty Boop. Now, Betty Boop, if you look at this Betty Boop cartoon character, draw attention first of all to her face. You see that's a rather very round face with round, large eyes, very small mouth, and so on. And all of these are the classic visual characteristics of infantilism. They say that's the baby face if there ever was one. What's provocative about the Betty Boop cartoon characters is how you take that head and then you stick it on something. When you look below the neck, you think that's not infantile. Okay. So there's this, as I say, this provocative juxtaposition between two different kinds of appeal. One, the appeal of the sort of the cute, the one that you want to nurture and protect, somebody who you really care about, and then this mature sexuality that exists below that. So why would some sounds be evocative of nurturing and protective behaviors? The obvious thing is that the response to these sounds is consistent with the biological goal of parenting. Imagine what deep problems we would have if we didn't find babies compelling and cute. Right? So it's not inappropriate to suspect that the perception of auditory cuteness has, in fact, an evolutionary origin. So this is not something that's learned, in fact, that there's something that's innate there, especially when you compare the sounds and how people describe it to the specific behaviors that are evoked by that. Well, let's move on into sort of the opposite side and look at sarcasm. In my lab, Joe Plazak did a very nice dissertation where he asked instrumentalists to perform in a sarcastic fashion. So sarcastic renditions were easily distinguished from happy, sad, and angry renditions by individual listeners. So I thought I'd give you an example. Here's a saxophone player playing Happy Birthday in a sarcastic fashion. Okay, so sarcasm in general might be regarded as a form of speech related to sneer or contempt, and there's quite a bit of research that's been done in the facial expression literature regarding this. So the disgust response, you see the elevation of the upper part of the lip and the constriction of the nasal passages. There's also another version of the disgust response, which is asymmetrical. It's just on one side of the face. The disgust response is that I find, like if I'm smelling something, I find this disgusting, but the sneer, the asymmetrical version of it, is a social marker, which says, I find you disgusting. And so you see an example of the sneer or contempt here. Okay. Joe Plazak analyzed recordings of performers' sarcasm using speech analysis software, and what he found was that sarcastic renditions showed statistically significant increase in nasality for some instruments. Okay, so what happens when you're doing this is that in the sarcastic facial expression, you're changing the nasal component to it, and you're adding nasality to the voice. So let's review. Consistent with the multimodal tendency of ethological signals, smiling exhibits both characteristic visual and characteristic auditory components consistent with sound size symbolism. Pouting exhibits both characteristic visual and characteristic auditory components, again, consistent with sound size symbolism. The pitch of the voice conveys friendliness or aggression, consistent with sound size symbolism, and the pitch of the voice is echoed in the movements of the eyebrows, consistent with the multimodal tendency of ethological signals. The cuteness we hear in a baby's voice is a combination of the high pitch and a 2 kilohertz resonance attributed to the shorter vocal tract length. These acoustical features coincide with distinctive visual features of the infantile face, such as the big eyes, the small mouth, and the round face. The sneer or contempt expression pinches the nose, causing audible nasalization of the voice, consistent with a multimodal signal. And all of these things that I've just discussed, all of these features can be observed in music. So, if we want to know which human-generated sounds are most likely to be signals, these are the sounds that tend to be accompanied by distinctive visual features, like smiling or contempt. Paradoxically, the way to identify which human-generated sounds are most likely to be cross-culturally recognized, they are the sounds that tend to be accompanied by distinctive visual features. If you want to know whether a particular sound has a natural or innate meaning, a useful heuristic, a rule of thumb here, is to ask yourself whether the sound tends to be accompanied by a distinctive visual element. Okay, so at this point you might be thinking, well, Huron thinks everything is a signal. So let me give you, just as a last example, an example of what I propose is, in fact, a cue. And it's an important emotion. It's the emotion of sadness. I'm going to claim that expressions of sadness amount to an ethological cue rather than an ethological signal. So first of all, it's important to make a distinction between sadness and grief. They're two very different states. Already in Darwin's book on facial expressions of emotion, he had made the distinction between sadness and what he called sorrow. So sadness is a low physiological arousal emotion. The heart rate tends to decline, breathing is shallow, and so on. Grief is a very different state. You have high physiological arousal, erratic breathing, there's all sorts of things, constriction of the pharynx, all sorts of things going on in grief. So I'm only going to make this claim for sadness, not for grief. So we know from other research about what makes a voice sound sad. This dates back to the end of the 19th century when Emil Kraepelin described clinically what he described as a depressed or sad voice. So a sad voice is quieter, it's lower in overall pitch, It's more monotone. That is to say, the pitch excursions are narrower. So when a person is happy or excited, the pitch goes up and down like this, but when they're sad, they tend to speak more with the pitch at a constant level. When people are sad, they tend to mumble more, so they'll speak with less movement of the chin and lips and so on. And finally, there's a darker timbre to the sound. In a series of studies we've done in my lab over the last number of years, we found that in the case of music that listeners deem to be sad, they conform to all of these features. Quieter, slower, lower in pitch, more monotone, mumbled. Now you might ask, what's the musical equivalent of mumbling? That's things like legato, avoiding the use of staccato, and so on. And a darker timbre. Even the instruments, you can see that some instruments have a darker timbre than others, so people will judge the viola to be a sadder instrument than the sound of a violin, or the cor anglaise to be a sadder sound than the oboe. Okay. People disagree about sad music. This was a surprise to us in the lab. What one person finds to be a sad piece of music, not everyone will agree about. What some call sad, others will call relaxing, tender, or peaceful. So you find a bifurcation with regard to a lot of New Age music, for example, where some people will hear lots of New Age music and they'll say, that's just sad music, sad, sad, sad. Whereas other people say, no, that's just relaxing music. There's nothing sad about that. There's also a strong cultural component to this. When we play North Indian music to Westerners, there's a strong tendency for them to describe certain kinds of music as sad, where the Indians will just object. They'll say, that's not sad at all, that's devotional music. What we've also found is that this is strongly related to personality. So people who score high on neuroticism in a personality inventory are much more likely to interpret musical stimuli as sad sounding than people who score low on neuroticism. So now we might ask the question, what do quieter, slower, lower pitch, more monotone, mumbled, and darker timbre all share in common? What do these features all share in common? And the answer is low physiological arousal. In fact, low acetylcholine, which you know peripherally, will make the muscles less tense, more flaccid, and also reduce reactivity, so the muscles will move slower. So think about it. The pulmonary muscles will relax, causing the subglottal air pressure to be reduced, which means that the voice will be quieter. The vocal folds will relax, which will tend to produce the pitch, make the pitch go down. The cricothyroid muscle, which is involved with most of the pitch excursion, will be more sluggish, so the pitch movement up and down will be slower. All of the muscles are the articulatory muscles, the tongue, the chin, and so on. They'll all be sluggish, and you'll end up with this mumbled sound. And then finally, what about the darker timbre? Well, when you have a relaxed face, the lips tend to pull away from the teeth. And when you have a smile, you move them closer, so the darker timbre has to do with a relaxed facial expression. They're all artifacts of low physiological arousal. What we call a sad voice has the same properties as a sleepy voice and a relaxed voice. Listeners can't tell the difference between a sad voice and a sleepy voice. We've just been working on this in our lab. So when you ask people, is that a sad voice or a sleepy voice, they can't tell the difference. What we hear is the sound of low physiological arousal, not sadness per se. Now, faces are described as sad, but faces can also be described as relaxed or sleepy. So let's take a look at this. This is work by one of my colleagues, Alex Martinez and his colleague. And what you're seeing here are manipulated facial expressions. The distance between the mouth and the eyebrows has been compressed in the left-hand photograph, and they've been lengthened in the right-hand photograph. And now you ask the question, which of the faces looks sadder? And there's no question about it. The one on the right is the one that people will say, that's a sadder-looking face. It's a longer face. Well, we're now engaged in the next version of this, which is which face looks sleepier. So we have to ask, why is a long face associated with sadness? And the straightforward answer is that what happens is the musculature just gets relaxed. Okay. So I showed you this photograph earlier as a paradigmatic example of sadness, but now let me tell you a little bit about the history of this photograph, because it's from a professional photographer's portfolio. And this child who was hired to pose for this was given a very specific instruction by the photographer for this photograph. The instruction was, make a neutral face. Make a neutral face, okay? So for the last couple of years, I've been riding the bus to work. And the one thing I'm always amazed at is, this is the classic thing, everybody looks sad on the bus. I think, in fact, nobody's sad. What's happening is they're just relaxed. They're not engaged in social interaction, so they don't flex the muscles the same way. We have a bias, I believe, to interpret the features as sadness rather than relaxation or sleepiness. Why do we have the bias? Because imagine two kinds of mistakes. If I mistake a person, I think that they're relaxed, but they're actually sad. Or I think that they're sad, and they're actually relaxed. Which is the more onerous mistake to make, right? You don't want to falsely recognize, you don't want to miss somebody who is actually sad, and you just think that they're relaxed. So I think this is the reason why the bias exists. Sadness exhibits no distinctive unique acoustical features. Sadness exhibits no distinctive unique visual features, and both the acoustical and visual features of sadness are shared with sleepiness and relaxation. So the features of sadness are all artifacts of low physiological arousal. Sadness appears to be a cue rather than a signal in the ethological sense. And as I mentioned earlier, I think grief is a completely different story. I think grief truly is a signal. And with that, I'll end. Thank you.
Questions for David? Can you come to the mic, or I'm going to take me too long to get to you, I'm afraid. Anybody close?
There was the whole association of low with threatening and high with non-threatening. But what about specific associations? Like, let's say somebody has an evil mother and a kind father. Could they reverse the association of what's threatening and what's
Sure.
kind?
So of course, for this presentation, I've compressed and left out a lot of things. So it's not actually true that a lower pitch voice is more aggressive, or for that matter, sadder. When you do the proper research, what you find is that it's lower than normal. Lower than normal is what people perceive. So, people normalize it according to what they expect. So if you're listening on the telephone to say you're talking to your mother or you're talking to your sister, and maybe your mother has a naturally alto voice and your sister has a more naturally soprano voice, your sister may be speaking in a lower pitch voice, which brings her down to the alto level. She may still be speaking with a pitch higher than your mother, but you will recognize that it's lower than normal, and so you will infer that it's sad. So these things are normalized. And by the way, this also happens with speech. People normalize the intention of the pitch use and prosody to the natural tessitura of the voice.
Hi, Andy Tubman, music therapist from SingFit. I have a question. Do you know any research that's been going on, or has there been, that basically looks at the conveying of information, like what voice, whether it's an older male voice, a child's voice, has the most effectiveness in general for a general population as far as conveying information, right? So just a generalized, is there any research that's kind of looking at that says like, oh, it's a female, middle-aged female with a high-pitched voice actually is received most effectively to translate into the general population most effectively?
Yeah, that's an excellent question. So the research on that's fairly sparse, but there is some research. And as you might expect, it's quite context dependent. So let me give you an example of one kind of voice that's quite appealing to people, but not universally, and it used to be much more popular decades ago. So in the 1950s or 1960s, if you tuned in an FM radio station, a number of years ago, you had this very characteristic sort of basso profundo bass voice, which was rather quiet. And there's this interesting thing that happens. In virtually every culture, there's a mythology of the gentle giant. So the gentle giant is someone who's physically very powerful, a male usually, but who's deferential and polite and loves children and all those sorts of things. And usually some sort of myth of something happens where the gentle giant, saves the day by doing something very altruistic. What we find with a low-pitched voice, what that conveys is power. But if you speak in the upper part of the range, what it conveys is sociability. So a very compelling voice is the gentle giant voice. That's the male voice that has a naturally deep voice, but in which the person is speaking in the upper part of the register and is speaking quietly. And that has that's compelling for some people. But it's, those voices have gone, you no longer hear those very much on the radio anymore. So it is context dependent. There are a few generalizations like the gentle giant voice, but, we should talk some other time about it.
So I'm going to ask the panelists to please come forward. That's Dr. Barry Ramo and Dr. Schlag, and also Connie Tomino and Mark Nykrug. And I'll let one more question go of David as we ask the panelists to come on up, so we allow the discussion to continue. Please, Stu.
Yeah. Hi, Dr. Huron.
Yes, sorry.
I wondered what you make of the tendency to regard minor tonalities, and especially the minor third, to represent sadness, which seems to be almost universally accepted, except that in previous eras it wasn't the case. And I could think of many minor tunes, like It Don't Mean a Thing If It Ain't Got That Swing, that are not sad. So can you talk about that?
Well, thank you for asking that question. We've done quite a bit of research on this. Unfortunately, there'd be another lecture on this. What I said earlier about lower than normal, it applies to the perception of scales. So you have to ask the question in any culture, what's the norm? And what we know for Western enculturated listeners, the norm and the expectation, if you play a melody to people that just is completely novel, we can show in the lab that they expect it to be in the major mode. And they're surprised when they've realized, oh, it's in the minor mode. So 75% of the music that you're experiencing is in the major mode. So what happens in the minor mode is you take some of those pitches and you lower them. Well, there's even room to lower some other pitches. You can take flat 7, for example, and that also makes it sad. If you take flat 5, it's part of the blues scale, which partly makes it sad as well. Now, there are other cultures. The classic example of this is in the Balkans with Bulgarian music, in which the minor mode, the equivalent of what we call the harmonic minor mode, is the most commonly used scale in traditional Bulgarian music. They do not use the major scale. The minor mode is the norm. And there's no association, then, to sadness. What am I saying? There's nothing inherently sad about the minor mode. What makes it sad is a normative expectation of pitches that are higher that you're now hearing as lower. And what we find, because we've done this research in the lab, when you do this cross-culturally, it's exactly the same thing. What makes a scale sound sadder is that there are some pitches that are lower than normal, and the norm is important.
Thank you.
Yeah.
Thank you.